Go to the basics of vectors for physics first, okay? You start from here. Can you see the parallelogram method?
Yeah.
Can. So what is the parallelogram method? First, we must understand how it works. So let's say you have a force A. You got an object here in the middle. Then A is pulling this direction, B is pulling this direction. Where will it end up?
Mm,
Common sense says that it will end up somewhere here, right?
really?
Yeah. Okay, for example, human being, okay, stand like that. Then someone pull here, and then another one pull here. He will move forward.
Um, I never experienced that before, so I don't know.
Can lah. You can ask your brother help to pull you. You see what happens. You get one fella pull here, and then another fella pull here, diagonal, about diagonal like that, right? You
Mm.
will move in this direction.
Okay,
Okay?
I think it makes a bit sense now to
Yes, yes.
me.
It's like that, lah. It's like that. So you have to first understand this part. So once you understand this part, you will understand what this one is all about. So you imagine you're standing here, red color part. So A and B are your two. I don't know if you have two siblings. So
I only
sibling
got one.
one. Okay, then your mother, father, right? Father,
Yeah.
mother pull you in two direction. You will end up going this direction. So this chapter, right? They want you to know exactly where will you be, or what's the force, what's the resultant force that you will experience. Okay, so how do we do that? We gotta create a parallelogram. What is the meaning of parallelogram? So we gotta create another. Okay, do you know what's a parallelogram?
Yeah,
Uh,
maths.
both sides are parallel, right? So
Mm-hmm.
that's why this method is called the parallelogram method, because you are drawing a parallelogram. So effectively, what you're doing is you draw something here because of this, okay, and then you copy B over here. So actually, the resultant force will be this direction to here.
Mm.
Okay. So what do we do? So the resultant force is here, from here all the way to here. Okay, so that's the idea. This one is the idea. Do you get the idea? Parallelogram method.
Kind of, yeah.
Okay, can. So we got to look at some example, okay, to see how it works. So anyway, this is the instruction. So let's take a look at an example. Okay, here's another one. Never mind, this one not important. Okay, so here's one example.
Mm-hmm.
So we have a mass of weight 4 Newton hanging on the end of a string. So the object is here. The object
Mm-hmm.
is here. Okay, so someone is pulling it 8 Newton here, and then there's also a pull force of 4 Newton downwards.
Mm.
So where is the resultant force? So the resultant force will be somewhere here.
Up. Not
Huh?
up, man. Not should it be
Uh,
up?
okay, slightly diagonal up. Wait, because upwards 8 and downwards 4. Correct. So it's very hard for you to determine where is it.
Mm.
You know what I mean? Just by looking, I cannot tell whether it's up or down. So we draw a parallelogram. We draw a parallelogram. So now this method, right, needs you to use your ruler. You see, 1 cm represent 2 Newton. That
Mm.
means you got to draw 4 cm here. Why? Because it's 8 Newton. 8 Newton equals to 4 centimeter.
Wait, so 1 Newton is
2 Newton is 1 cm.
oh
You need to actually draw the thing.
wait, is it already confirmed or some questions will give you like a different scale
You
to
can use
represent?
you can use your own scale. If you want 1 Newton equal 1 cm also can.
Really?
Yeah. So but of course sometimes we can look at your questions. Later we take a look at questions. Sometimes they give you the scale, then you just use the scale.
Okay.
Okay, so here in this example we use 1 cm represent 2 Newton. So 8 Newton will be 4 cm, and then 4 Newton will be 2 cm. Right?
Mm-hmm.
Okay, but where is the resultant force? So okay, we already done this. 8 Newton, 4 cm, 4 Newton, 2 cm. So the resultant force is it should end up somewhere here, right? So because it's 4 cm, and then you pull down 2 cm, right? So you should end up here. Then what you do is you take your ruler and you measure this. You measure the length.
Wait, why this one need, why like suddenly this one need pull down? I mean like at the left, on the left.
On the left, need what?
The
Sorry.
two, why is the 2 cm drawn on the left?
Oh, because downward 2 cm
But then, eh? But
up and
then,
down. Okay, you see, we draw the parallelogram method, okay? Let's start from the beginning. Where is the resultant force? It will be 2 cm down like that, and then, correct? Did I just draw a parallelogram?
so it's like that?
Can you see we drew a parallelogram? So this will be 2 cm, and then this will be 4 cm. But where is the resultant force? The resultant force is here.
Why?
The resultant force is the green color line.
Yeah, but.
Yeah.
Um,
Why? Because you pull, the object is here, so somebody pulls 8 Newton upwards, and then there's also a 4 Newton downwards. So you end up somewhere here.
Yeah, but then we just draw the parallel diagram to determine like that the more the accurate length, you see?
Correct. You draw to find, then you use ruler, right? You measure, the green color is 2.9 cm. 2.9 cm. And because, sorry?
Do you get 40 degree because I take 180 minus the current degree?
This one given you. This one they give you.
How where?
There. Angle 40 degrees.
Angle 40 with the vertical.
So they give you this 40 degrees.
But what if they don't give you like anything at all?
Okay, usually they will. If not, you can't draw a vector diagram, right? You can't create a parallelogram.
Yeah. Oh.
So usually there'll be some clue somewhere, right? But the idea, let's maybe we complete this question,
Okay.
Right? So the idea is you create a parallelogram, and then you find that this is the resultant force. You measure you use a ruler. You measure the distance is 2.9 centimeters, and because 1 cm equals 2 Newton, right? So 2.9 cm will be equals to just times 2, so it's 5.8.
Times 2?
Yeah. Correct? Times 2.
Wait,
1
which
cm
one?
to, yeah?
2.9 times 2?
Yeah.
Is it?
Yeah, because here to here times 2, so here also times 2.
Shouldn't it be 5.8 newtons?
Yeah, yeah.
I thought you write 3.8 newtons.
F5.
Sorry.
Bad handwriting. Okay, 5.8. So it's 5.8. Okay, so what does it mean? So the answer is that the resultant force is 5.8 Newton.
Okay.
So that's how we can then of course the other part is how do you get this angle 21.3? You measure, you use your protractor.
How to write the final answer?
This one, no? This is the final answer.
Then like why is it like 21.3 degree like measured to the horizon?
Use protractor. You know this one? Use protractor. You measure.
But why is it not? Why is it the length above and not below. I mean the angle above, not below.
Oh, because it moved this direction, it went this direction, and it's with respect to the horizontal. It went upwards. So anyway, this is just the description. Right, so the description is acting at an angle 1.3 to the horizontal. So this is just the description. Right, maybe we see a few more examples.
Oh, okay.
Can. So anyway, what's the key takeaway here? Key takeaway here is we draw and then we measure. We draw and we measure the length.
Okay.
To find the answer, you draw and measure the length. So maybe we see another example. Okay, so you see this thing? So an object is pulled steady speed 2 cables. There's one cable here and another cable downwards. Oops, wait, it's missing number. Downwards is at 45,000 Newton. This is 45000 Newton. Okay, so where will this thing end up? It will go straight, right? Somewhere like this, right?
Yeah.
Yeah, someone pulled, diagonal top and bottom, so it will go to the left. So we want to find out where exactly will it go. We draw a parallelogram. See the parallelogram? And the scale, we determine ourselves, 1 cm is 10,000 meters. Yeah, so this is 6 centimeter and here is 4.5 centimeter. So we draw a parallelogram. And you know that you end up here, then you measure 8.8 cm. Yeah, so 8.8 is times 10,000 is 88,000 meters. Is that alright?
Yeah.
Okay, so now let's take a look at your question. So that's the idea of a vector diagram. Upload your question. Okay, shall we take a look at the first one?
Yes.
Okay, so two forces 6 and 12 act at right angle to one another. And the force of 6 is represented by figure 2, but then SG. So because the other force is 12 and it's right angle, right? First you gotta measure what is the length, how many cm is this line? Do you have the question?
Yeah,
You need to take a ruler, to measure. How many centimeters is that?
Okay.
Ruler. I don't have a ruler.
I have.
Here don't have ruler. Eraser.
Damn. So. I think so. I'm black teddy bear. So. Okay. So 世界上。Okay.
Have you measured how many centimeters is that?
Okay. It's 6 cm.
6,
6 cm,
6
yeah.
centimeter.
Yeah.
Okay, so 6 cm. So what's the scale? 1 cm equal 1 Newton, right?
Yeah.
Then after that, you got to draw another line, 12 cm.
Okay.
Represent 12 Newton. So this has to be 12 centimeters. Okay. So using the parallelogram rule, right? You're gonna
Okay.
draw additional lines here as well as up. So this is 12 cm. Vertical is 6 centimeter. So where is my resultant force? You take your ruler again. You measure the length of this line.
Okay.
Yeah. Once you measure that, you convert back in terms of cm, right? You convert back to Newton. You will get the how many newtons are. That's over there.
Okay. Oh my god, it's a bit. Wait. I got
Okay.
13.5.
13.5. 13.5 cm, right? So
Yeah.
it's 13.5 Newton. Okay, if you are not sure, you can use Pythagoras theorem. Play cheat. It's 12, this is 6, right? So
Yeah.
6 squared equals to 6 squared plus 12 squared.
Yeah.
You can find h as well. Okay? But this question need you to draw, so you need to draw the entire thing. Okay, and next.
If I use Pythagoras theorem is inaccurate cause the answer is not 13.5. It's 13.4.
Never mind lah. So, but it can help you to check.
Yeah.
Okay, next one. So, a rock of 20 Newton is thrown in the air. Through the air. At a particular time, a force of 50 acts on the right angle of 45. So, an incomplete vector diagram is shown. You're supposed to find the magnitude of the resultant on the rock. Okay, so what do? Draw parallelogram. So we gotta see here how many blocks. Vertical 20 Newton, right? 1, 2, 3, 4. So here also go down. 1, 2, 3, 4. Okay? And this thing connect all the way here. Got it? Hello?
Yes, I can hear.
Okay, then where is the resultant force? Resultant force is here. Diagonal.
Oh.
Right? So it's diagonal. Resultant force diagonal. What do you need to do? Measure how many cm. They say 1 cm is 5 Newton. So you measure how many centimeter is the red color line. You will get the answer. Then they give you the scale, 1 cm 5 Newton.
I use ruler to measure myself.
Yeah, just measure.
How about it's not 5 cm, it's for 20 Newton I got 3.5 cm.
20 you got 3.5. Okay, you know why? Because you're using the book. This is the book, right?
Yeah.
Yeah, so the scale is wrong. This, in the actual exam, this will be on an A4 size paper and it is to scale.
Oh.
Scale will be accurate, but now it's a book. That means they convert from paper to book. So the scale will be a bit off.
Okay.
Yeah,
so I just follow the book. I just follow the book can already.
Yeah, just follow the book is fine. So don't worry about getting some decimal place wrong or what. Okay?
Okay.
Yeah, next. Wow, this 3 marks though. Wow. Learn this so easily.
This QRS.
Yeah, 2016. 3 marks. Next one. Okay, any question here?
No.
No, okay, next one.
Wait, sorry.
Yeah.
Wait, so the answer I will just write something cm to the magnitude of the horizontal
No,
or
the
vertical.
red color. You gotta measure how many cm.
Uh-huh.
Then convert to Newton because the answer is in Newton.
But do I need to write horizontal or vertical?
No, it's not horizontal or vertical. It's just diagonal. You must measure. Use ruler to measure the length.
But when do we need to write horizontal or vertical?
When you need here no need. Here don't have.
So
What do you mean horizontal or vertical?
like you know the previous question they were
This one?
no you know just now the page that you showed me which is not
The
my book you wrote
oh
wrote like horizontal.
this one
Uh kind I think so.
This one?
Yeah, oh yeah, this one.
Oh, you mean where do I need to write this? Is it?
Yeah, yeah,
Don't
yeah.
don't have. The question never asks you to do that. You
But
see,
how
the question
to
only asks how many Newton. This one,
oh
how many Newton? Right? They never ask you what is the direction. This one
okay.
also, how many Newton?
Okay.
They never ask what's the direction, so we don't need to draw the direction.
Oh,
Okay.
okay.
Okay. Last one. So what a television camera is supported above the playing area by two wire A and B. Force 60 Newton wire A, force of 70 in wire B. Draw a vector diagram at scale of 1 to 10 to determine. Okay, so here you got to draw some diagram. I think on your foolscap paper, it's paper 2. So you got to draw on the foolscap paper. 1 cm represents 10 Newton. So this will be 7 centimeter. This will be 6 centimeter. You got to measure the angle here.
Okay.
Okay, and then you draw a parallelogram. So same thing, parallelogram, parallelogram.
Give me paper.
Okay, so where will be the resultant force? Here. I highlight with green. This is the resultant force.
Give me one paper.
Okay, and then you measure how many centimeter. Green color part how many centimeter, and you convert back because 1 represents 10 Newton. You convert back, you will be able to find the how many Newton the resultant force.
Oh.
That's all. So basically for your this 10 series, right, all the questions rely on the parallelogram method.
Oh, so there's only this method lah.
Yep. Just use the parallelogram method. Don't need to think about other stuff. Okay, just draw a parallelogram and measure. Use ruler to measure.
Okay.
Yeah, that's all.
Oh, okay.
Yeah. Okay, anything else?
Nope.
No, okay, so sorry, I gotta stop here already, right? So
Okay.
that's all for vectors.